Hi, we meet again. Okay, salam sejahtera. We are going to look at this Lenz law from 5 physics. Okay, alright, hukum Lenz. Alright, kita tengok dulu definisinya. Alright, okay, we do it in English first. Lenz law states that an induced current always flow in such a direction so as to oppose the change or motion producing it. So what does it mean? All right, let's take a look at the Bahasa version. All right, okay. In Bahasa version, it is stated that hukum Lenz menyatakan arus yang diarahkan sentiasa mengalir dalam arah yang menentang perubahan yang menyebabkannya. So, maksud menentang perubahan yang menyebabkannya, alright, perubahan yang menyebabkannya itu sebenarnya adalah magnet. Alright, dia merujuk ke magnet. Maksudnya bila magnet nak masuk, arus yang diarahkan akan mengalir sedemikian arah agar hujung solenoid akan menjadi selatan juga. Alright, akan menjadi selatan. Alright, iaitu kita kata mau masuk tak dibenarkan masuk. Okay, jadi untuk pemahaman murid, alright, for you, your understanding, I have come up with my own theory. Magnet cuba nak masuk, bila kita cuba nak tolak magnet masuk, cuba nak masuk, magnet mau masuk, tak dibenarkan masuk. Alright, jadi macam mana tak dibenarkan masuk? Understood lah, dia menjadi kutub selatan. So it becomes south, then it will repel. It doesn't allow. Doesn't allow doesn't mean cannot go in. Alright, because we can push hard, then the magnet will go in. Is it okay? Alright, so if you put your eyes here, you will notice, alright, you will notice that the current will flow, alright, clockwise, because south is actually clockwise. Alright, okay, now we're going to see what happened when we pull the magnet out. Alright, okay, so we apply the English version. Induced current will flow in such a way as to oppose. Alright, this is south. So oppose the magnet from going out, meaning this must be north. All right. Okay. So north meaning if you were to put your eyes here, you're going to see is anti-clockwise. Is that correct? So bahasa version we will say like this. Bila magnet mau keluar, magnet tak dibenarkan keluar. So bagaimana tak dibenarkan keluar? Yang tak dibenarkan keluar maksudnya dia akan menjadi kutub utara di sini, north. Supaya dia akan tarik balik magnet, okay, agar dia tidak keluar. Jadi tak dibenarkan keluar, tak bermaksud tak boleh keluar, dia masih boleh keluar. Clear? Alright, itulah kita kata aplikasi yang kita perlu tahu. The application of Lenz law. Alright, so again, okay, I change it to south now. Alright, north. North want to go in, so current will be induced so that it will flow. Alright, it will oppose. Oppose meaning what? It must be going to be a north. Agree? Alright, so that the concept mau masuk tak dibenarkan masuk. Betul tidak? Clear? Let's take a look at the sentence. Alright, when the magnet is moved towards the coil, current is induced. Yes, correct. Alright, the end is induced to become the opposite, okay, pole, so that there is a force of repulsion. Clear? Alright. Okay, a force of repulsion. So actually the word here should be the same pole. The same pole, not opposite. Okay, so there is a slight mistake there. The same pole, all right, north want to go in, it become north. Clear? So there is a force of repulsion that exists. Clear? All right, the bahasa ocean masih ingat? Mau masuk, tak dibenarkan masuk. Clear? So south and south. So if you put your eyes here, all right, you will see that it is anti-clockwise. Okay, lawan jam. Clear? All right, so see what happened when we pull the magnet out. All right, okay, so anti-clockwise, you see the arrow. All right, the arrow will flow like this. Okay, so when the magnet is moved away from the coil, the end is induced to become the opposite. This is correct, opposite. All right, so when the north come out, it will become south. Okay, the opposite. Clear? It will pull. All right, it will pull. All right, there's a force of attraction that exists between the coil and the magnet. So the south will pull back the north. Is that correct? Okay, so it will be clockwise. If you were to put your eyes here, you take a good look, it's going to be a clockwise. Okay, huh? All right, so we're going to go through one more revision so that you will know. All right. When the sub want to go in, current will be induced. All right. Current will be induced so that it will flow. All right. The end of the coil here, it will flow. All right. Clockwise. All right. So that it becomes sub. Okay. Magnet mau masuk tak dibenarkan masuk. So sub and sub dia akan tolak. All right. So when the magnet is about to come out, current is induced to flow in such a way so that it become north. All right. It become north so that it will pull it back. Magnet mau keluar, tak dibenarkan keluar. So if you put your eyes here, it's going to be anti-clockwise. Okay. All right. So when you move in and pull out, you actually will overcome the opposing force. All right. When the magnet want to go in, not allowed to go in. So you have to push hard. When the magnet want to come out, you're not allowed to come out. Then you're going to pull hard. Agree? That's why you actually, okay, do work. Okay, work must be done. But this work is not wasted. Okay, not wasted, remember? Right? Okay, the work is actually converted to electrical energy. Okay, to obey the principle of conservation of energy. Supaya dia mematuhi prinsip keabadian tenaga. Okay, so that's all we do today. Till we meet again in the next session. All right. Okay. Bye. See you then.